then we need to pass the CSWA. But here in Mexico, we said it is better have more to be the better. I don't know how to translate it, but there is a sentence, a special sentence here in Mexico we use for that. So there is better to have more. Okay, Osulu said that he attended. It's nice people, and again, welcome everybody. Welcome the people that is entered right now. So Derek and Medar, let me know when we can start. Okay.
Yeah. Okay. And Tim, Emily, just before we start, for those who have just joined in, you are going to share a link where you can find the PDF. That's the WhatsApp group for UgandaSWUG that Emily will be discussing.
Okay.
Yeah. So let me share that link in a few, but Emily, you can start.
Okay. And again, welcome everybody. It's nice to be here with you. And I know you are amazing. You are an amazing group from Uganda, and maybe many are in another country, but let me share my screen in order to start. And please feel free to use the chat. I'm really happy that many people is using the chat right now to say hey, hello, to say I attended the last session. So please feel free to use the chat to make questions. Derek and Medar are going to help us to see the questions, and in order to not have any issue with the exercises, please use the chat. And let me start with this presentation here. So as I was saying, the session today is about assembly creation. If you remember, just to take a fast reminder, this is the journey you have to take in order to become expert. Starting from the associate, you are on point to start the first beautiful level, that is the associate level, and you have to take the road as a video game. In a video game, you should take all the levels step by step. This is the same. You should take it step by step, level by level, and well, that's why I'm here. I'm Emir Guzman, and I'm from Mexico. Last year, I was awarded with the Elite Engineer certification in the SolidWorks, in the 3D Experience SolidWorks world. And just if you remember, there are three main parts for the CSWA certification. The first part is about drafting. It's just a little part that I'm sure that all the people here is ready to pass. And the second part is about part modeling. And the third part that we are talking about today is the assembly modeling. Okay. Well, the main topics we have to cover today are this. The first main topic that you have to realize about is how to place the base part, how to place the first part we insert in the assembly file. It is important because this part allow us to make or allow us to place all the next components in the assembly. So the first part is it is important. And mates, how to use basic but also some advanced mates, and how to use coordinate systems, because as we know, there are many mass properties that depends on this. Mass center position, inertia moments, and how to make interference and collision detections. It is important. What is a rigid and a flexible subassemblies? We are allowed to insert assemblies into another assemblies, and those are called sub-assemblies. Well, those sub-assemblies can be in two states, and that's what we are going to cover today too. How to replace a component. There is a special command to replace a component, and it is important that you know how to use this command. So we have to cover many topics across many questions. So I feel sorry if I take many questions fastly, but you can go to the recording session in order to practice and in order to see the detail levels, okay? And as we see in the part modeling section, there are many best practices I recommend in order to pass this section in the exam. And the first one, I didn't write here, but the first one is practice and practice and practice and practice. That's why Derek and Medar are going to send you another exercises, and this is the best practice. Practice and practice and practice. And the second one is take your time to analyze all the questions. Take your time to make a strategy from the bottom. This is important. And it is important that you realize how many components there are, and which mates should I use to place all the components across the assembly, and where is the origin. This is important because sometimes you don't realize where is the origin, and you place correctly all the components, and then when you have to calculate the mass properties, the mass center positions, if you don't realize where is the origin, where is the correct place for the origin, you have run the question. So there's important. So take your time, be patient at the beginning, and make a good strategy from the bottom. The second practice I recommend is download all the files and make a clean copy in order to let all the original files without any change, and save a file for each question, as we see in the part modeling section. So, and make sure that first question is correct, because second, third, and fourth questions are dependent on the first questions. So if you make sure that first question is correct, there are 90% probabilities that you make it good in the next questions. Okay, so those are the best practices, and let's start with the first question here. And the first question here is about coordinate systems. And as we see in the part modeling section, we are provided with the instructions here, and the units we need to use, it's millimeters, grams, and seconds. We have to use three decimal places for the answers, and the assembly origin here is arbitrary. Okay, it says it is arbitrary, but if you see the images, you can realize where the coordinate systems is. And we have to create these coordinate systems. And the instructions are: create a new assembly and insert the part that is I don't know why, but I was muted. Okay.
Sorry.
Okay. Don't worry. And again, we have to create a new assembly, and we have to insert the first part that it is called base. And we have to create a coordinate system as shown in here. And we have to calculate the mass center position in millimeters. And as we see in the part modeling section, the first questions have many possible answers, and that helps us to realize if we are in a right way. So imagine that we download all the components that the certification provide us. These are the components, and I'm just going to start a new assembly here. And the first thing is to realize, sorry, I hit the sustainability application. And the first thing you realize is what the units are. If you need to change the units here, you can do it. If you had a template, you can use it. You just have to make sure that you are using the right units, okay? And as we mentioned, how to place the first component is one of the most important topics for the assembly. And we recommend that you place the first component making the part origin coincident with the assembly origin, as we can see here. And how to do it, how to fix the first component, making coincident the part and the assembly origin. Well, you just need to hit OK here in the insert component command. You just need to click OK. If you click in one point in the viewport, the assembly origin are going to be fixed at that point, and we don't want to do that. So instead of make a click here in the viewport, you just need to click OK in the insert component command. And as you can hear, and you can see here in the tree, the assembly origin is coincident with the part origin. So this is one of the best practice I recommend. And then I'm going to create a coordinate system here using the reference geometry tab. And these coordinate systems can be positioned in one vertex of the part, as I'm going to do here. And then we should use reference geometry. I mean, we can use this edge to orientate the edges, the axis for the coordinate system. So the x-axis needs to be in this positive direction, and the y-axis here should be in this positive direction. So we are allowed to place the center of the coordinate system, and we are allowed to orientate each axis in the coordinate system. The z-axis, this third axis, are going to be oriented by default if you define the first two axes. Okay? And we have here the new coordinate system, and then we just need to go to the evaluate tab in the command manager in order to hit the mass properties commands and calculate the mass center position. And an important point here, it is important to select the correct coordinate system. If we take this answer here, as we are shown here, it is going to be wrong because we didn't select the correct coordinate system here. And here, I'm going to do it. This is the correct coordinate system, and you see how the answer is changing. And the answer here is this. Okay. That is the letter D. So that's the first question. That's about how to make a coordinate systems and how to use it to get the mass center position. Okay. And what about question 2? Question 2 is about mates. We have to insert the pivot, the hinge, and the connecting rod subassembly in this file. And we have to make these components as is shown here. And then we have to get the mass center position. Okay. These are the components we have to insert, and these are the mates we have to use. And if you see the icons here, you can realize what the mates are. And we have to use with mates, we have to use concentric, coincident, angular, and parallel mates. Okay, many basics and one of the advanced mates. Okay, and if you realize in the files, we get from the certification, we don't have any connecting rod subassembly, so we have to create it. Okay, and we have to create this subassembly using in this case these two components. So let's do it. And for the first one, we have to, as we see in the best practices, we have to save for the first question here. And I'm going to make a copy for the second question. Okay, I'm going to start a new assembly as we did with this main assembly. And I'm going to browse. This command is activated by default each time you make a new assembly. I'm going to hit browse just to look for the for the cylinder component. And I'm going to place this component as we did for the first part in the first question. Okay. So then there is another component here that we need. So I'm going to go to the assembly tab, and then I'm going to hit this command, insert components, and I'm going to look for the next component I need. That is the connector here. And this is the second component. Second and the next components can be placed just clicking in the viewport. Okay, and pay attention here in the design tree. In the design tree, we have all the components we inserted in the assembly. And if you look at this character between the parentheses, this character tells us what is the state of each component. A component, as in a sketch, is relative to lines, circles, etc. But here in assembly, in a component, we can have different status. For example, if you look at this component, the cylinder, the state for this component is fixed. It means that it is fixed in a in a point on the space. If you look at this component connector, we have a hyphen between the parentheses. It says that this component is underdefined. And there are two state more for a component can be fully defined and over-defined. But in this case, connector is under-defined. It means that there are many degrees of freedom to move freely this component. Degrees of freedom is a linear or angular movement that is allowed for this component. So as long as we add a mate for this component, we are going to eliminate many degrees of freedom. Okay, let me show you. I'm going to insert a mate, and we have this command here in the assembly tab. I'm going to hit it. Okay, and we can see that all the mates are grouping in different tabs. We have the standard mates, the mechanical mates, and the advanced mates. Okay, and I'm going to use a coincident relation here. And I'm going to select the reference geometry to make it concentric. Sorry, it's not coincident, it's concentric. And I'm going to select this face and this face here in order to make it concentric. And then I already eliminate many degrees of freedom because I'm just allowed to move this component just in one direction. Well, two directions, one linear direction and one angular direction here. So that's why I was saying that as long as you add mate, you are eliminating many degrees of freedom. Okay, and I'm going to save this assembly. This is a connecting rod assembly. Okay, and then I'm going to continue with the exercise. I need to add the pivot component, and there is another way to add component instead of hit the insert component command. You just need to go to the Windows folders where you have the components, and you just need to drag these components to the viewport. There's another way to add components. I think it's an easy way to add component. Sorry, let me. How to become what? Let me close. Let me close this here. And we have to position this component. And I'm going to hit this command that it is called component preview window. This component preview window allows us to make components in an easy way. As you see here, the viewport is sectioning in two parts. And then I'm going to hit the mate command just in order to add some mates. So I'm going to add this concentric mate here for this and for this. Okay, coincident mate as it is shown in the images. So coincident here and here, and parallel mate here. Okay. So please use this component preview command as you can do it because it is easy to add mates between two components. Then I'm going to look in the Windows folder, the next component that it is the hinge. I'm going to drag the hinge to the viewport. And then I'm going to do the same. Right click to the component and then hit the component preview window. Okay. And I'm going to make the components again using concentric mate here for these two faces. And then I'm going to use an advanced mate that is called width. For the width mate, you have to select two pairs of faces. The first pair of faces are the width faces here, and the second pair of faces are the tab faces. Okay. And if you see here, and if you compare with the images, we made this component in a wrong alignment. So it doesn't matter. We just need to modify this relation, and as long as you add mates to the assembly, you can find those mates in this folder here. And you just need to flip the mate alignment here, or you just need to edit the feature, and you can use these buttons here to change the alignment. So don't worry about it. Okay, and then we just need to add the connecting row sub-assembly. The same way, I'm going to drag it to the viewport. And let me show you something important here. Well, first, I'm going to mate this component using concentric mate first for this and this face, and using width again for this width and this face. If you look at this, you can realize that you don't need all the time using two pair of faces. The system has the intelligence to position the tab face here, that is not a planar face, can be a cylindrical or circular face, and the systems place it in the middle of the width selections. So you can use planar, or you can use cylindrical or circular faces. Okay, and let me show you something here. If you remember, this component has some degrees of freedom. Okay, but if you try to use it here in the main assembly, you realize that you can do it. You are not allowed to use these degrees of freedom. Why? When you insert an assembly into a main assembly, when you use a sub-assembly, this sub-assembly can be in two status. Can be rigid or can be flexible. In order to allow the degrees of freedom to be here in the main assembly, we need to change
robot car. Here's the circuit.
Sorry. Okay. We need to change, in order to make the sub-assembly flexible, we need to change this sub-assembly to a flexible state. And how can we do it? We just need to right-click the sub-assembly, and we just need to hit this command here. And as long as you make it flexible, you are allowed now to use these degrees of freedom. Okay, and then we just need to make this component here. You just need to make concentric this and this. Don't be worried about this. You just need to rebuild using Ctrl+Q, and you just need to rebuild the assembly. And we have the second question already completed. Okay, And the question is about, if you remember, is about the mass center position. We have to do the same. We just need to hit the mass properties command. And we just need to be sure that we are using the correct coordinate system. And this is the center of mass. That is relative to the letter B. Okay? Well, let's go to the third question. And this is interesting. The third question is about collision detection. And the indications are where the units and decimal places remains the same. The assembly origin should be using the coordinate system we already created. And the indications are using the assembly from previous questions, rotate the part named pivot until collides with the part base, as shown. And the question is, what is the value of Q dimension in degrees? So, I'm going to save this and I'm going to make a copy for the question 3. Remember, one copy for each question. Okay, and in order to allow the rotation, we have to suppress this parallel mate. If you remember, we add a parallel mate between these two faces. And I'm going to go to the mates folder and I'm going to suppress using right click and this icon, this parallel mate. And now I'm allowed to do this. Okay, sorry, for the last question, I forget a mate. That's important to save a question for each file. Let me open the question 2. Sorry for that, I forget it. And I forget the angular mate, that it is 60 degrees. So I'm going to hit this mate. I'm going to write the value, and it's between these two. Sorry, let me check this. We have this. Okay. It's 60 degrees. Between this and this. Don't worry about it. We can change the alignment as we see. And let me re-evaluate the mass properties. And this is the correct answer. That is the same. Okay, as we see. Okay, and continue with that. I'm going to do the same. I'm going to add the mate because I forget it. 60 between this and this. I'm going to change the alignment here. And it's okay. So, well, we suppress the parallel mate in order to rotate it. And in order to make a collision detection, I'm going to hit this command, the move component command. And the move component command has the ability to activate in the options the collision detection here. And it is important also to check this option, stop at collision, because it gives us the ability, or the system has the ability with that option to stop the movement between components when it detects a collision. So when I select this option and this option, I'm allowed to rotate this component until it collides. Sorry, let me see here. And when a system detects a collision between components, it stops the components and it makes a sound. So I'm going to do it again. I'm going to hit the move component command. I'm going to select collision detection. I'm going to select stop at collision here. And this is the collision the system detects. And then we need to evaluate the value of the angle between these two faces. And I'm going to insert using the smart dimension command. I'm going to insert a reference dimension here between this and this face. And this is the answer. The answer is 89.5 degrees. Okay. So we already complete the question number 3. So this is about collision detection. The next question, question 4, we need to add components, okay? And the indications are about adding the part bracket to the assembly as we see in the images. And the question is about the mass of the assembly. The mass doesn't depend on the coordinate systems, so it is going to be easy to do it. I just need to save this question here. And I'm going to make a new copy for the question 4. Okay. We don't need this dimension anymore, so I'm going to eliminate it. And then I'm going to insert the new component. That is the bracket here. So if you realize the mass doesn't depend on the position of the component, so position of the component is not important here, I'm going to use the component preview window to mate as we see in the images. I just need to use a concentric mate here and here. And then a width mate between this width, so I don't know what, between this width and this tab. Okay. And what is the mass of the assembly? Well, we just need to evaluate the mass properties command, and this is the mass that is relative to letter D. Let me show you. It's letter D. So if the answer is about the mass of the assembly, doesn't matter the position of the components. So question number 5, interferences detection. Well, there is a main difference between interference and collision detection. Don't be confused about these words. A collision detection is when I move the components, okay? And an interference detection is when the components are static. So this is the main difference between these two kinds of detections. And in order to make an interference detection, we don't need to move the components. So the indications are using the assembly from the previous questions, you should insert, or you have to insert slider and link components and make them as shown. And the question is, which ones are interfering with each others, okay? And that's what we have to make the components. We have to use a concentric mate, a tangent mate, angular mate. Here, we have to use a distance mate, here a width mate, and concentric here. Okay, so let's go. And I'm going to make a clean copy here for question number 5. Okay. And I'm going to insert the next component. The first component I need is the, well, before that, I'm going to use, I'm going to make these two faces using an angular mate. Okay. Here between this and this. Okay, and just to make sure, because sometimes the system detects another portion of the angle. I'm just want to be sure that is 88 between these two faces. Here and yes, it is 88. Okay. And what's happened with this? Well, don't worry about it. We just need to change the alignment here or edit this mate. If you change the alignment many times, maybe you have the right way. Why? I don't know. To be honest, I don't know why the system take this behavior sometimes, but you just need to change the alignment many times. Okay? And well, then I'm going to insert the next component here, that is the link component. I'm going to drag it here, and I'm going to hit the component preview window, as we see in previous questions. And I'm going to make it concentric between this and this face. And then I'm going to use this mate. That is a distance mate. When we use a distance mate, we have to write the value of the distance, that is 4.3 here, and we have to select the pair of faces. Okay, and then, sorry about it, we missed the alignment that is important for this. I don't know why it is doing that, but okay. And then we just need to add a concentric mate between this and this here. Okay. And then I'm just going to insert the next component, but in order to change the game, I'm going to hit the insert component command, and I'm going to select the slider component here. It is the same, it remains the same, but the procedure changed for each case. Okay, I'm going to hit component preview window, and I'm going to make those components first using a tangent mate between this and this face. You can make a circular and a planar faces tangent. here. So in order to use a tangent mate, you need a circular and a planar face. Okay, then I'm going to select this and this face here in order to make it concentric. Okay, just let me be sure about the position of the concentric mate that I think is okay. And then we just need to use an advanced width mate between this pair of faces and this pair of faces here. And again, sorry for the change on the position. I don't know why the system is taking this behavior, but we just need to change the alignment here again. If the alignment doesn't change, let me. Okay, I don't know why it is doing this. Sorry for that. Sorry for that. I don't know why he's doing this. I'm just start from the bottom. That's why it is important to save the questions here. Let me eliminate this angle. And reposition the components. Sorry for that. I don't know why the system is taking this behavior, but I just eliminate the mate, the angular mate, and I'm just going to add the mate again. There is 60 degrees. Okay. That is the. Sorry, I don't know. I'm really sorry. I don't know why this is taking this behavior here. Let me start from the bottom. Or let me again eliminate this angle. And let me add this angle again. Okay. I don't know why it's over-defined, but I think the positions are correct. And just let me make the interference detection here. I'm just going to go to the evaluate section and make an interference detection. I'm just going to hit the interference detection here. I'm going to calculate it. And the system give us a result. And for each interference here, there are 2 interferences detected. And if you see the details of the interferences, you can realize where which components are interfering with each other. That is the base, pivot, link, and slider here. And this is the answer. Okay, pivot, slider, and sorry, I don't remember. Again, pivot, slider, link, and base. Okay. Again, sorry about it. I don't know why this is taking the behavior. And let's go to the next question here. Okay. The next question is about design changes. And we have to use the assembly we already created for the question 5 and make some changes. If you look at the changes are this mate. We have to suppress the 88 angular mate, and we have to change this angle from 60 to 85. Okay, and the question is about the mass center position. So we just need to change. We just need to change here the angle. First, let me save here the question. And let me make a copy for question 6. And what about design changes? Well, we need to change the angle here. We need to use 85 angle. I don't know why, but the problem was corrected. I think the mistake, not the mistake, but the problem was about the 60 degrees angle. I don't know why. I think it's correct, but let's go. And then we need to suppress this angle here. And if you remember, we already create this parallel mate, and we have it here. We just need to right click it and we just need to unsuppress it. Okay. So we have the angle that is 85, and we have the parallel mate between these two faces. Okay. Okay. I realized what was the problem. Sorry for that. We have we have here this I don't know how to say this tangent mate, but we need to change the alignment here. Let me show you why. I'm going to save, and I'm going to edit the tangent mate here just to change the alignment. Why to change the alignment? In order to put this face between these two faces, in order to put this face inside this slot. So the alignment for the mates, it is important. Sorry, I didn't realize about it, but that was a problem. Okay, well, I corrected here, and we already positioned in a right way all the components, and then we just need to hit the mass properties command. Okay, it's here. And using the coordinate system 1, this is the mass center position here. That is relative to the letter B. Let me show you. This is the correct answer. Okay, so please be patient. Please make sure that you are using the correct alignment for the components. And let's go to the last question. The last question is about replace components, and the units, the decimal places remains the same. The assembly origin is about the system we already created, coordinate system 1, and using the assembly from previous questions, replace the component base with base 2. And we have to review each operation and mates in order to make the previous assembly, in order to make the new assembly look the same way as the previous one. And the question is about the mass center position. Okay, so we have to replace. I'm going to make a clean copy here for question 7. And then I'm going to replace this component. And we have a special command in order to replace components. To not look for it in all the commands, we have this search tab. Here we can search for commands, and we just need to type a word to find the command. The command is named replace component, and we just need to select first the components we want to replace, and I'm going to browse the new component that is base 2. Okay, it is important also to check this option here, this last option, in order to reattach all the mates these components already have. Okay, and before we hit OK, the mate replace wizard is going to start. And this is helpful to replace the geometry to redefine each mate this component has. And in order to make it step by step, the system helps us to replace this geometry step by step too. So for the first mate, we need to select a face relative or a face similar to this in the new component. And the face similar to this in the new component is this one. This one here. Okay? And maybe we need to change the mate alignment. We can do it with this button. Okay? Don't be worried about the position of the components. If you realize the important thing here is position in a right way this coordinate system we already created, and then we just need to reevaluate the mass center position related to this coordinate system. So the position of the component doesn't matter here. Well, we are going to go to the next reference geometry. We need a planar face like this, and let me show you. Can be this here. Okay. And then for the last reference, we need a face like this. This is the face. And this is the face. Okay. And we already changed all the reference geometry. I'm going to start. I'm going to hit OK. And we already replaced the component and the mates. And for the last part, we just need to redefine the position of the coordinate systems and the direction of the axis. We just need to edit the feature, and we just need to select the new position that is relative to this vertex here. We need to orientate the x-axis using this edge. we need to orientate the y-axis here, and by default, the z-axis is defined. Okay, and then we just need to hit the mask properties command. Be sure that you are using the right coordinate system, and this is the answer. Okay, so in order to replace a component, you don't need to eliminate the component, you just need to use the replace component command, and using this command, the mates can be reattached. So, well, this is question 8. Question 7, sorry. And people, that's all. We already completed part. To be honest, in the CSWA certification, the questions are easier than this. I wanted for you to make or to answer harder questions in order to be prepared, in order to be well prepared for the certifications. For the CSWA, you might not need to use the interference and the collision detection, but it is important to know how these commands behave in order to be well prepared. So that's all. Let me see the questions. Medar and Derek, it's time to questions, or you wanna say something? Okay.
Yeah, thanks, Emery, for that wonderful session. Read through the questions. I see Mwesgo David asks, what's the meaning of component alignment?
Component alignment. Oh, okay. Component, let me share the screen again. Well, component alignment is referring about the positions, the possible positions components can take when you add a mate. If you remember, let me show you this. When we add this mate, this angular mate, one possible position using 85 degrees between these components can be this we see here. But if we change the alignment using this button, we have 85 degrees too, but the position changed. So mate alignment refers to the relative position a component can take using the same mate. This is the answer. Okay.
Okay, thanks for that. Manya Lawrence asks, recap on how to make a sub-assembly flexible in the main assembly.
It's about flexible sub-assembly. Yes, and let me show you how. If you want to make a sub-assembly flexible, you just need to right-click the sub-assembly in the tree, and you just need to hit this button here. If you want to make the sub-assembly rigid again, you just need to hit again this button. But as you can see, when I make again this sub-assembly rigid, we have problems. Why? Because if you put a subassembly in a rigid state, degrees of freedom of each individual component in the subassembly are not allowed in a parent assembly. This is the parent assembly when we have all the components, and this is the subassembly, and this subassembly has two components. If you remember, this connector component has many degrees of freedom. If you make this subassembly flexible again, these degrees of freedoms are allowed in the main or in the parent assembly. That's the difference between flexible and rigid subassemblies. And you can do it in all the versions of SolidWorks. You just need to right-click and hit this. Okay? You are on mute, Derek. Okay, yes.
Thanks, Emery. Thanks, Emery. Anyone else with any question?
Let me say. Sorry, let me say something that I forget in some of the questions. And what about the other states a component can take? If you remember, I mentioned 4 states for a component. A fixed state, if you fix a component, it means that you make it fixed in a point on the space. But the difference with a fully defined component, if you have a fully defined component, it's a component that doesn't have any degrees of freedom because you restrict it or restrict them using mates. And the difference between fully defined and a fixed component is that you don't need to add any mate to make a component fixed. So that's the difference. To make a component fully defined, yes, you need to add mates in order to restrict the degrees of freedom. And when you have, if you look at this tree, when you have anything between the parentheses, like in here, in here, in here, it means that these or those components are fully defined. Okay? Well.
I see another question here from Mwisuga David. Mwisuga asked, couldn't we also make the components in the main assembly without creating a sub-assembly? That is Mwisuga David.
Sorry, can you repeat, please, Derek?
It says, couldn't we also make the components in the main assembly without creating sub-assembly?
Yes, you can do it. It's the same.
Yes.
It's the same.
Yeah, but I guess here we're following the instruction in the question, isn't it?
Yes, the instruction is because the instruction in the questions. Let me show you here. It's because the instructions in the questions was this. You have to add a connected rod subassembly, but at first we don't have this subassembly. That's why we need to create it. But yes, it's the same. It doesn't change the answer if you add directly to the main assembly.
I see Amanya. Individual components have an effect on the center of mass of the assembly.
Sorry, I missed the first part of the question.
He's saying, do the origins of the individual components that are forming the assembly, their origins, do they have an effect on the center of mass of the assembly?
No, it doesn't have any effect in the center of mass. If you are using the correct coordinate systems, it doesn't matter.
Okay, I see. Amanda Lawrence asks, is it possible to change the position of the coordinate system?
It's possible to change the position of the
coordinate system.
The connect systems. What do you mean with the connect system? I think you mean this. If you mean this, yes, you can change it. But in this case, you are allowed to change it with the angular mate. If you change the angular mate here, that's because the way we made those whole system. If you change here to 60, it also changed the position of this component here. I don't know if you mean connecting system. This, but that's the way.
Lawrence, are you answered, or I unmute you so that you can ask your question better?
I meant the coordinate system, the XYZ position. Are you getting me?
You are asking about if you can change manually these positions, these coordinates. Yes, you can do it.
Window.
Yeah, you can do it. If you use this command, you are allowed to manually overwrite these values here. You can change it one by one. And it's a good question because I remember in the CSWP, that is the next certification you have to take, there is 1 or 2 questions about this in the assembly part, in the 3rd segment. I remember you have to change manually. I think it was the mass